Let's look at this circuit. This is a combination circuit, 12 volts, 60 ohm, 30 ohm, 10 ohm. Now, we are taking conventional current, where current is flowing from positive. At X, current splits into the current at the top branch and the current at the bottom branch. Let's have some variables to standardize first. Okay, the first variable is I60. I60 represents the current in the 60 ohm. I30 represents current in the 30 ohm resistor. I10 represents current in the 10 ohm resistor. Now, because 30 ohm and 10 ohm are in series, they can be combined to form 40 ohm. So this is the equivalent circuit from here. Now, at the same time, your background knowledge, you should know that because this branch here, XY, is parallel to the EMF, to the battery of 12 volts, and this branch here is parallel, they are all parallel, so therefore the EMF is equals to the potential difference across the 60 ohm resistor, which is 12. But take note, the potential difference across the 30 ohm resistor is not 12. The potential difference across the 10 ohm resistor is also not 12. Okay, this is a common mistake. It should be the potential difference, the sum of the potential difference across the 30 ohm and the potential difference across the 10 ohm resistor will give us 12. Okay, so this is very important. Please write it down. So let's take a look at the first question. Combined resistance. This one should be no problem. So R combined, you can write R total, RC, R effective, doesn't matter, all the same. So 1 over 60 plus 1 over 40. Okay, over here you can see, over here 40, so I'm bringing the 40 here. Alright, so then make sure you remember to invert it, then you will get 24 ohms. Find the current through the cell. The current I through the cell is equivalent to the total current. It's the same. And the total current, you must take V total over R total, right, using the Ohm's law equation. So therefore, V total will be the EMF, which is 12. Total resistance is found in the first part here. So you just divide by 24 and you will get the current. Okay, remember your list SF, 2SF, 2SF. So final answer here should be also 2SF, 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 2SF. Next, state the potential difference across 60 ohm resistor. So just now I've already talked about it already. Here, potential difference across here is actually the same as this. It's the same, It's the same as this. So, which is 12. Okay, so the answer is 12 volts. If you are asked to explain why, very simple. You just say that 60 ohm resistor is connected in parallel to the 12 volt drive cell. Okay, that's all. Find the current through the 60 ohm resistor. So in this case, the current in the 60 ohm resistor is given by V60 over R60. Okay, and the voltage will be 12 over 60, which is 0.20 amperes. Find the current through the 30 ohm resistor. 30 ohm resistor over here. So let's take a look. Current through the 30 ohm resistor, alright, is now you see you don't have the voltage. I don't know what is the voltage or the potential difference across the 30 ohm resistor, so I cannot use the formula. But I know something. I know that total current is equals to I60 plus I30 at X. At X here, the current splits into 60 and 30. Let me erase the rest. That's confusing. Okay, so therefore you just take this one and then you can solve. So therefore current in the 30 ohm is current minus I60, current in the dry cell minus I60, 0.50 minus 0.20, 0.30 amperes. What is the current in the 10 ohm resistor? Next part F. Current in the 10 ohm resistor, I30 is the same as I10. So I30 equals to I10. So current in 10 ohm resistor is the same as current in the 30 ohm resistor, which is 0.30 amperes. If you are asked to talk about the reason, very simple. You just say that 10 ohm resistor is connected in series with 30 ohm resistor. The next part is quite okay. Hence means use the answer from part F, alright, to find the potential difference across 10 ohm. So potential difference across 10 ohm is the resistance times the current. And we know that the resistance is 10. The current has been found over here. So 0.30, and the final answer will be 3.0 volts. Let's do a very important thing, our checking. Now we know that the voltage across the 10 ohm resistor is 3.0 volts. Let's take a look at the voltage across the 30 ohm resistor. Let's take a look at the voltage across the 30 ohm resistor, which is R30 times I30. So 30, I30 is given over here, so just sub inside here, times 0.30, I'll get 9.0 volts. Let's check. Voltage across 10 ohm resistor plus voltage across 30 ohm resistor equals to 3.0 plus 9.0. You get 12.0 volts, which is the same as EMF. So the answer is correct.